everyone and welcome back. Today's video is about a real criminal operation that Microsoft discovered in 2025. It was called Storm-2139, and what makes it fascinating and terrifying is that it was not a sophisticated hack. There was no zero-day exploit, no nation-state level attack tool. So Storm-2139 built an entire criminal business using six standard security mistakes. Mistakes that your thousands of organizations are making right now with their AI deployments. Let me give you a real world analogy to set that scene. Imagine if you own a hotel. You give each guest a master key, but instead of giving them a key card that expires when they check out, you give them a physical key that works forever on every door and never needs to be returned. Now, imagine one of your guests leaves that key sitting on a table in public coffee shop. Sometime someone finds it, they make copies, they sell those copies, and suddenly strangers are walking into your hotel, using your facilities, running up bills, charging everything to the original your guest's account. Okay, this is exactly what Storm 2139 did, except the hotel was Microsoft Azure OpenAI Service. The master key was an API key. The coffee shop was a public GitHub repository. And the bills ran into tens of thousands of dollars per victim. Okay, so that is what the story is. Now, let's move to slide 2. Okay. So, like what happened? The criminal supply chain. Okay. So, somewhere in Pennsylvania and New Jersey, real estate, real companies, developers for writing code and pushing it to the GitHub, completely normal day activity. Something every developer does dozens of times a day. But buried in those code commits were a 52 character alphanumeric string, Azure OpenAI API keys. Okay, the developers had hard coded them directly into their configuration files. Maybe they were in a hurry. Maybe they planned to remove them later on. Maybe they did not even think about it. Storm 2139 was watching every public GitHub repository automatically. The moment one of those API keys appeared in a commit, within minutes their scanners had captured it. Now, here is what makes Storm 2139 really clever. They did not just use that stolen key themselves. They built a business that is, think of it in like a drug supply chain, but for AI agents. Okay, the creators were engineers. They figured out how to exploit Azure Open AI APIs. They built the tools. They cracked the problem once. Think of them like the manufacturers. The providers were the distributors. They took the your data tools, packaged them up, and sold access at a different price tiers. Okay, so basic plan, premium plan, enterprise plan, a fully functional criminal marketplace. Think of them like the wholesale. Okay? The users were the customers. They paid a subscription fee and got access to the Microsoft Azure OpenAI infrastructure, completely bypassing all the your content safety filters to generate content that violated Microsoft's acceptable use policy. So primarily non-consensual your intimate imaginary, they needed zero technical skills. Okay, they just opened the app and typed a prompt. Okay. The most important thing to understand here is the creator solved the technical challenges once, and then an unlimited number of users benefited from that single breakthrough. That is what makes AI-based criminal services so dangerous. The economics of scale work entirely in the attacker's favor. Okay, so that is what actually happened. So now the attack chain. Okay, so the MITRE attack and ATLAS mapping. Okay, so let me walk through how the attack actually worked and step by step using the MITRE framework that actually your professionals use to classify the attacks. Okay, the first step is reconnaissance. Now, Storm-2139 ran automated scanners against your public GitHub repositories 24 hours a day. They were looking for a specific pattern, the format of an Azure OpenAI API key. It is a 52 characters long. Once you know the pattern, finding it in a public repository is like searching for a phone number in a public directory. So real world example, it is like a thief driving slowly through a neighborhood looking for your houses with open windows. They're not breaking it in. They're just looking, and when they find one, they note the address and some back later. Okay. The second one is your initial access, step two. So with a stolen API key in hand, the Storm 2139 simply authenticated into Azure OpenAI Service. No MFA, no conditional access policy, no IP restrictions. The key was accepted from any IP addresses in the world, 152 character string, and you were in. Real world example is like that, that it is like, using a lost hotel, your key card. So you found it parking lot, and then you walk to the room, you tap it and open the door, and the hotel has no idea are in the guest. Okay, you're not in the guest. So now the step three, your defense evasion. So here is what it gets clever. Storm 2139 built a custom proxy tool that routed all their malicious your requests to Cloudflare tunnels. They hid their real IP address, and they altered the request parameters, especially the endpoint address and deployment ID, to bypass Microsoft's your geographic restrictions and content sector filters. Real world example, you can think of like that way, that imagine the hotel now has cameras watching and enters each room. So the thief puts on a disguise and uses a side entrance that the cameras do not cover. So same access, but not now invisible. Okay. So four is your execution. Okay. They built a front-end tool called DE3U, hosted on a GitHub, that gave paying users a simple text prompt interface. Type what you want, press enter. The tool sent the request directly to the Microsoft DALL-E3 deployment. But it had stripped out all the Azure's content moderation API calls. The safety filter was gone. So, like real world, if we map it in a real world scenario, it is like someone removing the speed, limiter from a hire car and renting it out to people who want to drive as fast as they want. Okay, the car is still the hire company's car. The fuel cost still goes on the original customer's account, but the safety guardrails has been removed. Okay. So the five is your resource hijacking. Every image generated, every text completion produced, Microsoft build it to the victim or organizations whose API key was stolen. Individual victims reported. bills in the tens of thousands of dollars. For compute, they never use. For content, they never requested. Okay. So the sixth step is impact. The jailbroken AI access sold as a paid subscription service. Non-consensual intimate imaginary imagery of celebrities generated at scale. Okay. Other policy violating content you're produced and destroyed. Okay. All using Microsoft, all using your Microsoft, um, your. Basically, all using Microsoft's infrastructure, all built to legitimate the organizations. Okay. So the critical thing I want you to take away from this slide is Storm-2139 did not break the AI model safety training. They bypassed the infrastructure around it. Okay. So the model itself, the GPT DALLE, was working correct. The security architecture that was supposed to protect it had been left wide open. Okay. So now move to slide 4, the 6 misconfigurations. The misconfiguration 1, static long-lived API keys. Okay. So imagine like giving key, giving every employee at your company a physical office key and never expires. Work on every door and cannot be deactivated if lost. So that is what an Azure OpenAI API key is by default. So once key full access forever. Okay. So that is what compare these of how modern authentication should work. A temporary badge that expires after 1 hour only 1 hour only opens the specific doors that employee needs and automatically deactivates the moment something suspicious happens. Okay, that is what managed identity provides, but most organizations never switch. Misconfiguration 2 is API keys hard coded in public repositories. Okay, this is the equivalent of writing your house alarm code on a sticky note. And you're sticking it to the front window. You would never do it intentionally, but developers do it with API key is all the time, putting them directly in code, meaning to remove them later and then forgetting. GitHub has a feature called push protection that would have blocked this commit before it happened, so it was not enabled. Okay, so this is your misconfiguration 2. Misconfiguration 3 is no anomaly detection on consumptions. Okay, imagine your electricity supplier sends you a bill of for 50,000 units when your normal usage is around 500. So would you notice immediately, right? These victim organizations had no equivalent system for Azure OpenAI token consumption, no baseline, no alert, no notification. The criminal usage ran for months, billed for the victim before anyone noticed, and some only noticed when they saw the invoice. Okay. The misconfiguration number 4, no API management gateways. Okay. So no API management gateway. So think of Azure API management like a hotel. Your constraints. Every request has to go through the constraint first. The it takes. Are you authorized? Are you asking for something reasonable? Is your request formatted correctly? Storm 2139's parameter tempered attack alerting the deployment IDs to skip content your moderation would have been caught all I mean at the that is your constraints desk immediately, but there was no constraints. The request was directly to the room. So misconfiguration number 5, the stolen API keys your worked from any IP address in the world, including through Cloudflare proxy tunnels designed to hide the attacker's real your location. Okay. And then configuration number 6 is no key rotation. The stolen keys remained valid for the entire duration of the attack. There was no automatic rotation, no expiry, no revocation triggered by anomalous usage. Okay. If keys had been rotating automatically every 30 days, which Azure Key Vault can do with zero application downtime, the attacker's access would have cut off on the next rotation, even if the left was never detected. Okay, so now move to slide 5. What should have stopped them 6 fixes? Okay. So now the good news is even like every single of this misconfigurations had a direct fix, and every fix uses a standard Microsoft Azure service that most organizations already have access to. Switch from API keys to manage identities with Enter ID authentication. Okay, this is most important fix, and it is also most impactful. A managed identity has no secret, there is no password, there is no key, there is no credential that can be stolen, copied, or shared. When your Azure application needs to call Azure OpenAI, it sends a request to the Enter ID saying, "I am a specific Azure resource." Enter ID verifies the identity and issues a temporary token valid for 1 hour. That can only be used by that specific resource. So Storm 2139 entire attack chain starts with stealing a static API key, remove the static API key, and attack chain never start. So that starts. So this is I mean nothing to steal. So fix 2 is your Azure Key Vault for any key that must exist with automatic rotation. Sometimes yeah, so that is what it is important, because you genuinely cannot use managed identity immediately. Legacy applications, third party integrations, short your migration periods. In those cases, every API key must be must live in Azure Key Vault, never in code, never in an environment variable, never anywhere in the a developer could echo accidentally committed. Key Vault rotates key automatically on a schedule you define every 30, 60, and 90 days. Okay. So fix 3. Now Azure API management in front of every API endpoint. API management is your main your concern. So every request to Azure OpenAI must pass through APIM first. Okay, APIM applies rate limiting. So even if a key is stolen, the attacker cannot drain your credits faster than you defined in threshold APIM enforces an IP allow list. Okay. Now, fix 4 is Microsoft Sentinel consumption monitoring with automated response. Okay, build a baseline for normal Azure OpenAI usage for your organization. How many tokens do you normally consumes per hour, pay per day, per week? Okay, so then create a Sentinel analytic rule. If consumption's velocity exceeds 3 times the 30-day baseline, fire an alert, add a store playbook if the alert is configured anonymously, automatically suspend the API key and notify that security team. Okay, so this can be done. Then fix 5 is your GitHub Advanced Security with push protection. So GitHub Advanced Security includes your secret scanning. It knows the pattern of an Azure Open API AI API keys, just as it knows the patterns of AWS secret GCP keys and dozens of other credential types. So push protection is the specific feature that blocks a commit containing a matching pattern before it reaches the repository. And the sixth one is your Microsoft Purview for AI governance visibility. Okay, Purview shows you which identities and applications are calling your Azure OpenAI endpoints. When an unknown application like Storm-2139 proxy tool starts making calls, Purview flags it and as an your unrecognized client. Okay, so so yeah. So we have already covered this sessions. Okay. So your uh, the lesson we have learned. Okay, and closing. Okay. So let me close with the single most important insights from this entire incident. That Storm 2139 did not break Azure OpenAI. The model did not fail. Microsoft's AI safety research did not fail. The DALLE3 model was not compromised. Storm 2139 found the door that customers had left open. A static API key with no expiry, no scope, no monitoring, and they worked through it. Then they sold tickets to everyone else. Okay, the model was never the problem. The model was never the problem. The infrastructure around it was. Okay, so this is a lesson that every organization deploying AI services needs to, I mean, internalize right now. AI security is not just about everything your model has been safety trained. It is about whether the API keys, the network controls, the consumption monitoring, and the identity architecture around your model met the same security standard as your most critical, enterprise systems. Okay. And also for the CISOs watching this, your action item this week is to audit every Azure OpenAI API keys in your tenant, find everyone that existing in application code, every environment variables, configuration files, or everywhere or anywhere it could reach a code repository. The answer tells you your Storm 2139 exposure is under an hour. Okay, so that is what it is. And for the cloud architects, design Azure OpenAI from day one with managed identity authentication APIM as mandatory requirements, not optional additions you add after deployment make it insecure pattern. Static API keys in application code architecturally impossible. Okay. For DevOps engineers, enable GitHub Advance your security push protection across every repository in your organization before your next working day ends. Okay, one developer, one API key, one public repository. This is all Storm 2139 needed to built the criminal business that became a federal lawsuit. Okay. Uh, So I will finish with a question for the comments. Are you running Azure OpenAI service with static API keys authentications today? Just reply yes or no. Or if you reply yes, I will share the specific Sentinel KQL rule that detects Storm-2139 style consumption anomalies against your Azure OpenAI deployment, and I will share the exact three commands needed to migrate your application to manage identity authentication. Okay, so thank you for watching. If this case study was valuable, subscribe and follow me for more real world AI security and Azure security content. Okay, so I'm Dhritiman Banerjee signing off for today. Thank you for watching, and bye for now.